Hello everyone, today in this video I will solve some chapter 9 exercise questions, that is 9.8, 9.9 and 9.10. Now move on to our first question, that is 9.8, and the question is a piece of copper having a rectangular cross section of 15.2 mm into 19.1 mm is pulled in tension with 44,500 Newton force, but using only elastic deformation. Calculate the resultant strain. Firstly, we will write what is given here. As we know that area of rectangle equals to length by breadth, so length equals to 15.2 mm and breadth equals to 19.1 mm. Firstly, we will convert millimeter into meter. Then area of cross section of rectangular copper piece equals to 290.32 into 10 to the power minus 6 meter square, and tension equals to 44,500 Newton, and value of Young's modulus equals to 120 into 10 to the power 9 Newton per meter square. As we know that Young's modulus equals to normal stress by longitudinal strain, so we have to find the longitudinal strain. So for that, the formula becomes longitudinal strain equals to normal stress by Young's modulus. So also we can write stress as force by area. So we get strain equals to force by area into Young's modulus, and after all using all the value that we know, we get a final answer of strain equals to 0.00128, and that is the answer. Now move on to our second question, that is 9.9, and the question is a steel cable with a radius of 1.5 cm supports the aircraft at a sky area. If the maximum stress is not to exceed 10 to the power 8 Newton per meter square, what is the maximum load the cable can support? Firstly, we write what is given. Radius equals to 0.015 meter and stress equals to 10 to the power 8 Newton per meter square. Since we know that area equals to pi r square, so we get a area that is 0.007065 meter square. Now we have to find the load. As we know that stress equals to force by area, so force equals to stress into area. So after using the value, we get a final answer for force equals to 70,650 Newton, or also we can write it as 7.065 into 10 to the power 4 Newton, and that is the answer. Now move on to our last question of this video, that is 9.10, and the question is a rigid bar of mass 15 kg is supported symmetrically by 3 wires, each 2.0 meter long, those at each end are of copper and the middle one is of iron. Determine the ratios of their diameter if each have to have the same tension. Firstly, we will write what is given, that is mass of rigid bar equals to 15 kg and wire length of each equals to 2 meter. So we have to find the ratios of diameters of copper and iron. So as we know that Young's modulus, radius equals to diameter by 2. So after squaring both the side, we get r square equals to d square by 4. Now we will use it in the formula of Young's modulus, that is force by area by strain. Also we can call that as Young's modulus equals to force by area into strain. After using the value of areas, radius, we get Young's modulus equals to force by pi d square by 4 into strain. From that we get Young's modulus is inversely proportional to diameter square. So therefore we have to find the Young's modulus of copper by Young's modulus of iron equals to diameter square of iron by diameter square of copper. Now we have to find the diameter of copper by diameter of iron equals to under root Young's modulus of iron by Young's modulus of copper. After using the values of Young's modulus of copper and iron, we get a final answer for this. Diameter of copper by diameter of iron equals to 1.25, and that is the answer. Thanks for watching. If you like this video, like and comment for more videos. Thank you.